Did you know that numbers have secret codes? Seriously, all around us, in the most unexpected places, there are hidden patterns just waiting to be cracked. And get this, some of the most amazing codes are written right into the fabric of nature itself. So, this quote, it's from a mathematics textbook, but it's pointing to something incredible, the Fibonacci sequence. Now, this isn't just some boring classroom exercise. It's a real deal code that pops up over and over again in the real world. I mean, just think about a sunflower or a pine cone. The number of spirals you see, totally not random. You'll often find numbers like 8 and 13 or maybe 21 and 34. And yep, you guessed it. Those are Fibonacci numbers, right next to each other in the sequence. It's basically nature's own super efficient packing algorithm. So the big question is, how do we learn to read these kinds of codes? Okay, so to crack any code, first you've got to learn the language, right? So let's dive in and break down the basic vocabulary of these number sequences. This is going to be the key that unlocks everything else. All right, first things first, what is a sequence? Well, it's really just a list of numbers that follows some kind of pattern or rule. The main thing to remember is that it's not random. There's a logic behind it. Like, if you look at 3, 6, 9, 12, 15, you can feel the pattern right away, can't you? Now, every single number inside one of these sequences has a name. We call it a term. So in our example, 3 is the first term, 6 is the second term, and you got the idea. It's just the lingo we use to talk about each piece of the code. And when you have terms that are right next to each other, like the 6 and the 9 here, we call them consecutive terms. And listen up, because this is important. Figuring out the relationship between those consecutive terms, that's how you crack the whole code. So, how do we actually describe that relationship? Well, we use something called the term-to-term rule. You can think of it as the secret set of instructions, or the algorithm, that builds the entire pattern from scratch. The term-to-term rule is pretty much exactly what it sounds like. It's the rule that tells you how to get from one term to the very next one. So for our old friend, 3, 6, 9, 12, the rule is super simple. Add 3. And just that one little instruction can create the whole pattern forever. Okay, your turn. Let's test out your new code-breaking skills. Take a look at this sequence. 2, 6, 10, 14, and so on. What do you think? What's the term-to-term rule here? Can you figure out the secret instruction? All right, let's walk through it together. Step 1, you look at the difference between the first two terms. So 6 minus 2 gives us 4. Okay, step 2, we've got to check if that's consistent. Is 10 minus 6 also 4? Yes. What about 14 minus 10? Also 4. Perfect. So our rule is add 4. And once you know that, you can predict what comes next. 14 plus 4 is 18, and 18 plus 4 is 22. See? Easy. Now, one more thing. Not all of these codes are built the same. Some of them have a definite stopping point, while others are just designed to go on forever. And that brings us to a really important idea, the difference between finite and infinite sequences. And honestly, the difference is super simple. A finite sequence, well, it's finite. It has an end. It just stops. But an infinite sequence like this one, it just keeps on going forever. And the way you know, the big clue, is those 3 little dots at the end. Whenever you see that, it's the math symbol for this pattern never ever stops. And there you have it. Just like that, you've learned the basics of the language of sequences. So let's do a super quick recap of all the code-breaking tools we just added to your toolkit. Okay, so remember, a sequence is just an ordered list of numbers with a pattern. Each individual number is called a term. When they're next to each other, they're consecutive terms. The secret instruction to get from one to the next, that's the term-to-term rule. And finally, a finite sequence ends, but an infinite one, that's the one with the 3 dots, it goes on forever. Hey, if you had fun cracking these number codes with us, do us a favor and hit that like button and share this with someone you think would enjoy it. And definitely drop a comment below. We really do love to hear what you think. So I'll just leave you with this one last thought. Now that you know the basic language, where else are you going to spot these hidden codes? I mean, they're everywhere. From the petals on a flower to maybe even the rhythm in your favorite song. What other secret number patterns are you going to find out there in the world?